Hello and welcome. From the 2023.4 Typhoon HIL Control Center software release, it's possible to represent multiple electrical wires by a single connection line, which we call an electrical bus. Additionally, some electrical components now support vectorization, allowing a single schematic component to represent several ones. In this tutorial, we explore how we can create electrical buses and how to use the electrical component vectorization feature. The example we are going to follow can be found in the Examples Explorer. Search for Electrical Buses and Component Vectorization, and then click Open Model. This model is divided into 3 parts to better demonstrate the basic concepts. On the right side of the first section, we can find resistors and current measurements connected in a 3-phase configuration. With the help of an electrical bus component, we can merge the 3 connections coming from the measurements into a single connection, like wires inside a cable. The only parameter we need to define for an electrical bus is the bus size. The bus size defines the amount of unidimensional terminals of the component. Let's display terminal dimensions so we can visualize the bus sizes. To do this, we first validate the model to calculate the dimensions, and then click on Model, Display Terminal Dimensions. We can see that there are 3 unidimensional terminals on the right side, and the multidimensional terminal of the bus is size 3. Now, notice that the terminals of the voltage source VS1 and of the ground component GND1 are also size 3. This is possible due to another feature, the electrical component vectorization. A list of all components that support this feature can be found in the documentation links in the description of the video. There are 2 ways that an electrical component can be vectorized. The first one is by entering a list of values to one or more of its properties. This is the case for VS1. The voltage property is set as a list of values, 100, 200, and 300 volts. This means that 3 voltage sources will be generated during compilation, with each one connected to a different wire of the bus. Each voltage source will have its own voltage value, following the order defined by the list. The second method for vectorizing electrical components is simply by connecting the component to a bus and leaving property values as scalars. The component will inherit the bus size in this case, just as GND1 is doing. The circuit in the second section is electrically equivalent to the first one. The difference is resistors and current measurements are also vectorized. Since we need to connect each of these resistors to the ground, we need a bus merger. The bus merger joins all bus wires into a single electrical node. The merging point can be made available as a terminal from the mask, and then we can connect the ground component to it. Finally, let's move on to the third section. The bus selector allows us to select specific wires from a bus to create a new one. Let's double-click it. On the left side, we must define the expected bus size. This populates the All Bus Wires list with wires we can choose from. Wires with marked checkboxes appear on the Selected Bus Wires list, and we can easily reorder them. Signal processing inputs and outputs of vectorized components inherit their electrical bus size. Although ground components represent the same electrical node, for the validation process the bus sizes must match. Enabling this connection results in validation failure. Now let's compile the model and open it in HIL SCADA. The variable names created for a vectorized component comprise the name of the component followed by the wire number between parentheses. In Part 1 and Part 2 groups, we can see that individual currents measured on R1, R2, and R3 match the currents on the vectorized resistor R4. In Part 3 we have a vectorized source of bus size 3 connected to the bus selector. Only wires 1 and 3 are selected, and this results in a no current on phase 2. The selected wires are also reordered in the bus selector, and we can see the effect in the new size 2 bus. We hope these new features enhance your experience and help you simplify your multi-phase circuit schematics. For more information, please access our online documentation via the links in the description below. Thank you for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL Academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.